Welcome to this eLearn Security video lesson on imaging a suspect's USB drive using Access Data's FTK Imager. In this video, we are going to create a forensic image of a suspect's USB drive using Access Data's FTK Imager. When performing a true investigation, you should use a write blocker and attach the USB to it before performing this task. In this video, we will explain the process, but will not be attaching the USB drive to a write blocker. Before we start creating our forensic image, let me show you the disk of interest. We can see that by going to the Computer Management Console and then click to the Disk Management utility. Scrolling down, we see that the suspect USB drive is mounted and attached to the drive letter Z, and it has a FAT32 file system. Additionally, the size of the USB is 7.31 gigabytes. To begin the acquisition process, let's start the Access Data's FTK Imager. Now, let's go to File, then Create Disk Image. Here's the Select Source window, where we can select the source evidence type we'll be dealing with. For this scenario, let's choose Physical Drive and select Next. From the drop-down menu, let's select the exact USB drive we want to forensically image. Scrolling to the end, let's choose the //./physical drive 3 -lexar jump drive USB device 7 GB USB and then click Finish. At the Create Image window, let's click the Add button to select the location where we want to store our forensic image. Here's the Select Image Type window, where we need to select the type of image we'll be using. Let's select the AFF type and click Next. Now, we want to add some information to go with the evidence we are creating. Let's fill out the evidence information we see. When entering the evidence information, you can add your own information and prefixes that you find more comfortable with, and that is easy to explain to your team. Now that all the information has been input, let's click the Next button. Here we have Select Image Destination. Let's click Browse to navigate to the location for storing the evidence we are taking and select that location. Let's select a new directory within our Cases directory, Case 002. Next, let's create a directory for the USB. We'll name it USB 01, assuming that it's the first USB that will be acquired and is related to this case. Let's create another directory inside the USB directory called Images. This is where we'll store the forensic images for this USB drive. After finishing and clicking OK, let's go back to the Select Image Type window. In the image file name excluding extension field, let's name this forensic image USB1_image01, which should clearly indicate that this is for the first USB evidence and the first image for it. In the image fragment size megabytes, let's change it to 0, as we don't want to fragment this image. In other words, we're not interested in dividing this image into smaller parts. Now let's select the Use AFF Encryption option and then click on Finish. This immediately displays the AFF encryption window, which I will use to add my password for this image. As you can see, I'm going to leave these two options selected. We already know that the first option is for verifying the images after creation. In other words, checking whether the hashes match or not. The other option is to create an Excel sheet of all the directories and files that are currently in the drive we are imaging. These are very useful options, so let's leave them selected and click Start. As you can see, the imaging process has started now, and we can see the time elapsed. An estimation of the time remaining, the image source, the destination where we are storing this forensic image, and the status of the tool we are using. The video will be paused here as it will take a few minutes to process. It won't take too much time since we're only forensically imaging a 7 GB drive. The imaging is finished, and FTK Imager will start the verification process. This is done by calculating the hash values of the original disk and the forensically created image. We can see the percentage of megabytes verified, the elapsed time, and the estimated time remaining to finish. After the verification process is finished, we have a window showing the name of the forensic image, the number of the sectors, and the computed and reported hashes for both MD5 and SHA-1. Let's maximize the window so we see the details. We can also see that the computed and reported hashes match for both hash functions used. There are also no bad sectors found during our acquisition. Let's close this window and the Creating Directory Listing window, which shows that FTK Imager managed to create a directory listing successfully. Now let's check what files have been created for cases, then case 002, then USB 01, and finally the image directory. As you can see, there are 3 files. The first one, which has the biggest size, is the true forensic image of the USB drive. The second one has the content of the directory listing in it. And the final file is a simple text file with the details of the acquisition performed using FTK Imager. Let's open it and see what's written there. On the first line, we can see the name of the tool and its version that was used to create the forensic image. We can also see my name on the examiner's line. Additionally, the details that were entered during the acquisition can be read here. Further down, we can see more information. Under the Computed Hashes section, here are the hash values for both the MD5 checksum and the SHA-1 checksum. Under Image Verification Results, we can see when the verification process started, when it finished, and if the hashes computed are verified or not, which, as you can see, are verified. Also, on this line, you can see the name of the forensic image that was used. Here, we can see the number of cylinders and bytes per sector that has been found on the drive we acquired, and finally the sector count, which gives us the exact number of sectors that was copied. Let's close this window. Now, let's open the Excel sheet and have a look at what's there. Let's expand the columns in this document so we can see what sort of information FTK Imager has stored. So, we see a column for the name of the file on the disk drive. We also have the full path to this file, or in other words, its location on the disk. We have size of the file, the creation date, and the date when it was modified. There are also 2 additional things, the access column and a column indicating whether the file is deleted or not. Don't worry about this information now. We'll come back to this later when we go into the file system module. Let's go ahead and close this for now. You may notice the size of the disk we just acquired. If you recall, the USB disk size was 7 GB, and this one is only 336 megabytes. If you're wondering why, the answer is easy. We're using an AFF forensic image format, and this type of image has compression capabilities. Before I finish this video, I'm assuming the suspect had a directory on the drive with child pornography within one of the directories. Let's also assume you don't have the time or even space to take a full image of the disk drive. We can use the FTK Imager to create a forensically sound image of a directory. Let's do that by going to File, then Create Disk Image. On the Select Source window, let's choose the 4th option, Contents of a Folder, and then click Next. Please read this message carefully so you're aware of the type of image you are creating and what type of evidence it will hold. I'll explain all of these in the next module when we talk about file systems, so don't worry. For now, we need to understand that there are some limitations when considering this type of forensic image. Finally, before clicking Yes, we can see the message also explains which versions are supported, as well as the version of the FTK Imager. We're now presented with a new window that is asking us to enter the evidence source path. Let's browse to the USB, and then select the PIX directory and click Finish. Now, we need to select the location where we will be storing our forensic image. Let's click Add, and then fill in all the evidence item information. Since this is part of our second case, I chose case 002, but as this is the second evidence, we will choose 002 for the number. The rest you can fill in as you find suitable. One important thing, though, is not to forget to add your name. Let's now add the exact location for storage by clicking the Browse button, then navigating to the location of interest and selecting it. This time, since it isn't an image for the whole disk drive, we're not going to store it in the Images directory, but straight beneath the USB 01 directory. Let's add the name for the forensic image, USB1_PIXDIR_image01, which means that this is the first image of the PIX directory found in the first USB. Where you store it all is up to you. This is not something you must stick to. We also don't want to fragment the image, so let's make sure that the image fragment size, megabytes, is set to 0. Let's also leave the compression ratio as it is, 6. Now, if we select the Use AD Encryption option and click Finish, we see an error message saying that we can't use an image fragment for this type of image to be 0, where 0 means no fragment. We need to choose something greater. So, let's use a different number here and then press Finish. Now let's enter the password for the forensic image twice and click OK, and then press Start on this window to proceed. This concludes our video lesson on imaging a suspect's USB drive using XS Data's FTK Imager. Thank you for joining us.